No one could get the aircraft carrier running again. Not the engineers flown in from across the globe, not the tech teams who'd serviced the world's most advanced military systems. Weeks passed with no solution, until the general brought in a quiet, retired Navy veteran no one had heard of. What happened next didn't just fix the engine. It humbled every specialist in the room and reminded the military why some wisdom can't be taught, only earned. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. In the twilight of his years, Commander Silas Grant had made peace with silence. He had once walked the length of steel decks echoing with power, overseen hundreds of personnel, and answered to the weight of America's naval command. But now his days were slow and unhurried, spent in a small seaside town called Heron's Watch, a place where salt clung to windows and the seagulls always arrived before sunrise. His home sat on the edge of the cliffs, modest and weather-worn, much like him. A pair of binoculars rested permanently on the porch railing. He hadn't used them much in the last year. After 35 years of service, Elias had quietly vanished from military headlines, drifting into civilian life like a tide retreating from shore. His hands, once precise in their command of nuclear systems and complex propulsion modules, now trembled slightly when lifting his coffee mug in the morning. The medals on his wall collected dust. The world no longer asked much from Silas Grant, and he didn't offer much in return. His neighbors knew him as the man who walked with a limp, fed stray cats, and always said thank you to the grocery store clerk. They had no idea that he had once written emergency protocols for malfunctioning destroyer turbines, or that his final assignment involved quietly preventing a catastrophic breakdown on a carrier lost in a storm surge. Elias never spoke about his service. He didn't like how some people flinched at the weight of military talk. He preferred listening over speaking, the kind of listening that remembered small things like which engine model growled too much when it was off-center, or which vibration frequency meant something deep in the core was failing. But those memories were locked in the vault of his mind, accessed only when his dreams brought him back to the open sea. Each morning he sat on that porch in silence, watching the horizon as if half expecting a signal to emerge from the waves. Most days, none came, until one day it did. It wasn't a signal in the sky, or the shimmer of something strange at sea. It was a knock on the door just before noon. 3 firm raps, too practiced to belong to a salesman or neighbor. Elias opened it to find a young officer in a freshly pressed uniform and a civilian technician behind him, both standing stiff as statues. They didn't need to explain who sent them. Elias had been expecting, without knowing, that the Navy would one day come back. They explained it quickly. The USS Armitage, an aging but heavily upgraded aircraft carrier, had experienced a complete propulsion failure during post-refit testing. Dozens of specialists had already inspected it. No one could find the root cause. With every failed attempt, tensions climbed. Naval officials were under pressure, the press was asking questions, and the deadline for the carrier's deployment loomed. Someone in the top brass had mentioned Elias's name. A gamble, they admitted. Desperation, some said. But General Broussard, a grizzled commander known for trusting his gut more than tech reports, had insisted. "Bring me Grant," he had said, "and bring him yesterday." Elias didn't respond right away. He looked past the officer, past the road and the cars, and stared out to where the ocean met the sky. His fingers curled around the porch railing. They weren't asking for help. They were asking him to return to a world that had moved on, yet something stirred in him, the part of him that never really decommissioned. He nodded once, packed a single bag, and within 3 hours he was en route to the Navy base where the Armitage waited, docked like a beached leviathan, silent and broken. The younger officers who first saw Elias step aboard had trouble hiding their skepticism. He didn't look like the solution. He looked like someone's retired grandfather who'd accidentally wandered onto a restricted vessel. His back was straight, but slow, his eyes clear but quiet. He didn't arrive with fanfare or technical equipment. Just a small notebook, an old oil-stained watch, and a pair of scuffed boots that had probably touched every deck between Norfolk and Yokosuka. No one greeted him with applause. In fact, most of the specialists avoided looking directly at him. They were the best in the country: MIT graduates, propulsion experts, AI integration consultants. Their pride was only rivaled by their frustration. Weeks of analysis had yielded nothing. Systems checked out individually but failed when unified. Something invisible, something deep, was wrong. And this old man, they assumed, wouldn't change that. Elias didn't argue or explain himself. He walked the deck slowly, laid a hand on the steel walls like he was greeting an old friend, and asked for silence. Not data, not projections, just quiet. The team reluctantly stood back as Elias closed his eyes and stood perfectly still, listening not just with ears but with memory. He was home again, not in the past but in a familiar kind of crisis. And deep in his bones he could already sense that the Armitage wasn't just broken, she was misunderstood. That was the first mistake the experts had made, and it wouldn't be the last. The USS Armitage, docked along the naval shipyard of Colfax Harbor, was not the kind of vessel that blended into the background. She towered over the surrounding dry docks, her steel flanks stained from years of salt and storm, yet gleaming in certain places with fresh rivets and new paneling. A recent overhaul had outfitted her with state-of-the-art propulsion diagnostics, hybrid energy modules, and an AI-linked engine monitoring system that was supposed to reduce failure detection time by 90%. In theory, she was the Navy's mechanical masterpiece, powerful, efficient, and smarter than any of her predecessors. But theory, as it turned out, bowed in the face of practice, and the Armitage had refused to cooperate with her upgrades, like a stubborn creature that had been altered against its will. Around the massive vessel, the shipyard buzzed with an uneasy blend of activity and anticipation. Forklifts and tool carts moved methodically along the supply roads, while men and women in jumpsuits and uniforms clustered around diagnostic stations and briefing rooms. The air smelled of oil, ozone, and sea brine. Security personnel moved with extra vigilance, mindful of the fact that this wasn't just any ship. They were sitting on a multi-billion-dollar embarrassment that threatened to humiliate the Navy in front of the world. Journalists hadn't been allowed close, but word had gotten out. The Armitage was crippled, and no one knew why. Inside the ship, tension oozed from the walls. The engine room had become a battlefield of quiet frustration and clipped voices. Engineers who once cracked jokes now muttered into headsets, with brows furrowed in disbelief. Specialists walked around with iPads and handheld sensors, their screens full of numbers that made no sense. Propulsion control showed full power distribution across all 3 primary channels, yet the engine refused to engage at full capacity. Fail-safes triggered even when overridden manually. Redundant systems reported normal status while critical alarms blinked without cause. The whole ship had become a riddle, and every attempted solution only deepened the confusion. As one technician quietly muttered in the break room, "It's like the ship knows it doesn't want to run." This was the world Silas Grant walked into, a vessel trying to scream but silenced by layers of misinterpretation. A team of brilliant minds, so entrenched in data they couldn't feel the heartbeat of the machine. He didn't blame them. These were men and women raised in a different era of naval engineering, where algorithms replaced intuition and updates were expected to solve what instinct once resolved. But ships, Elias believed, weren't just machines. They were living histories, an accumulation of decisions, wear, stress, and subtle habits that no computer could ever fully translate. As he moved through the Armitage's underbelly, Elias noted the layout differences from older carriers. The corridors were narrower in certain sections to make room for smart cabling. The insulation was newer, but the ventilation grates told stories of heat pockets forming in awkward places. He passed by a room filled with server racks pulsing with low lights, where a technician gave him a confused look before nodding reluctantly. No one had told them why this man was here. Some assumed he was a consultant, Others thought he was part of internal oversight. A few whispered that he might be a last-ditch PR move to buy time before the media storm arrived. The control deck, once the heart of command, had been outfitted with so much new tech that it felt more like a science lab than a warship. Elias walked through slowly, absorbing the changes. Touchscreens had replaced many manual switches, and holographic interfaces flickered over control stations. Yet despite all this, something was missing. There was no hum, no rhythm. Ships had a pulse. He could always feel it, even when nothing moved. But here, it was like the Armitage was waiting for someone to actually listen. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. He paused beside a maintenance wall panel that had been opened and closed so many times the screws had worn their threads. A small humming vibration was pulsing through the metal, one that seemed out of phase from the rest of the system. Elias rested his hand on it. No one else had noticed. Or perhaps they had, but dismissed it. To him, it was as clear as a distress call. Not in volume, but in inconsistency. He didn't say anything yet. He just kept walking. Outside, a storm had begun to roll in from the east. Thick clouds gathered over the coastline, painting the sky in slate and iron. A low rumble of thunder groaned above the bay, and technicians moved faster to secure loose equipment. On the ship's flight deck, jets had been covered and sealed, and most operations were moving indoors. It was fitting, Elias thought. The Armitage herself felt like a storm waiting to break, power trapped behind layers of misunderstanding. Inside the command tent near the dry dock, General Broussard watched the clouds and sipped a mug of black coffee, his eyes flicking toward the ship now and then. He hadn't told the press about Grant. He hadn't told many in command either. If this didn't work, he'd be mocked or worse, reprimanded. But he wasn't a man who needed approval. He was a man who'd once served with Silas Grant 30 years ago, when a reactor had gone cold in the middle of the Pacific, and Grant had brought it back online using nothing but a voltmeter, a flashlight, and a hunch. Broussard didn't care about protocols. He cared about results. Back aboard the Armitage, Elias entered the auxiliary engine room, where a team of junior engineers were working through yet another checklist. He asked them to clear the space for 10 minutes. Most of them resisted. One even challenged him, asking for clearance credentials. Elias didn't flash a badge. He just spoke the name of a system component, a legacy module buried deep in the substructure, and explained how its harmonics might clash with the ship's new vibration dampening system, causing phantom feedback loops. The silence that followed was absolute. None of them had considered that. Most of them didn't even know the ship still had that module. They left quietly. Elias knelt down beside a conduit, removed an old panel by hand, and looked into the beating heart of the Armitage. The wiring wasn't faulty. The data wasn't wrong. But someone, in their effort to modernize her, had forgotten to respect her origins. That, he thought, was always the danger with progress done too quickly. They had tried to overwrite legacy with innovation. Now the ship was caught between identities, like a voice trying to sing two songs at once. Elias closed his eyes again. The ship was speaking, and he would be the one to translate. The conflict aboard the USS Armitage was not just mechanical. It was cultural, ideological, and generational. At the helm of the diagnostic operations stood Dr. Lucas Mendez, a civilian systems architect contracted through a joint military tech initiative designed to streamline naval modernization. Mendez was not military, nor did he pretend to be. With his tailored button-down shirts, designer glasses, and ever-present tablet in hand, he moved through the carrier's corridors like a man walking through a machine he believed he had already mastered. He was a genius by most conventional standards, published in technical journals, keynote speaker at defense tech conferences, a former MIT lecturer who had, at 39, designed the fail-safe protocols now running beneath every modern battleship in the fleet. Mendez had been flown in to supervise the final integration of the Armitage's upgraded systems and to ensure that its next deployment would be a case study in operational perfection. But it wasn't. It was a disaster, and he didn't take that lightly. Mendez had not come alone. His hand-picked team of systems engineers, AI analysts, and hybrid propulsion specialists had been working in shifts, poring over diagnostics, testing line voltages, recalibrating sensors, and running simulated power-ups through the ship's learning-based control systems. Their confidence was rooted in data. Every calculation pointed to the same conclusion: the ship should be operational. But the Armitage had refused to engage full thrust without cascading failsafes, activating across subsystems that appeared normal in isolation. Mendez insisted it was a software integration issue, one that would resolve itself once the last firmware pass was complete. But when days turned into weeks and the ship remained inert, his frustration began to show in clipped orders and silent glares. He viewed the older members of the Navy's internal team with mild contempt, especially those who clung to legacy thinking. The idea that someone could feel a ship's problem rather than calculate it infuriated him. His entire worldview was built on quantifiability. If it couldn't be measured, logged, and reproduced, then it was either superstition or outdated intuition. And when General Broussard had unceremoniously authorized the arrival of Silas Grant without a formal introduction or briefing, Mendez's irritation turned into open disdain. To Mendez, Grant's arrival was not just an insult, it was sabotage. He believed the Navy was allowing desperation to override reason. They had brought in a relic from another era, a man with no access to the ship's proprietary interface protocols, who didn't even use modern diagnostic tools. It was an affront to progress. He'd watched from a distance as Elias walked the ship like he was sightseeing, pressing his palm to the bulkheads and standing silently in engine corridors like some kind of monk. Mendez dismissed it all as theatrics. He shared this opinion freely with his team, and their skepticism grew by the hour. What Mendez didn't know, what he couldn't allow himself to believe, was that his own methods, brilliant as they were, had a blind spot. The Armitage was not built entirely under his supervision. Much of her original skeleton, the critical mass of her structural identity, came from a design over 2 decades old. The hybrid upgrades had been bolted on top of decades of accumulated operational memory. In the eyes of modern software, this memory was noise, but in Silas Grant's eyes, it was a language, one written in microvibrations, airflow harmonics, and tension patterns across the ship's hull that no AI would recognize because it had never sailed into combat, never weathered a storm, never made last-minute course corrections under fire. Mendez believed that the ship's problem stemmed from flawed programming logic or corrupted baseline data. He ordered his engineers to wipe and reinstall the core operational modules 3 times in 12 days. Each time, the system stabilized for a few hours, only to fail again under live load simulations. He blamed the Navy's hardware technicians. Then he blamed the shipyard workers. Then, reluctantly, he began to blame the original design specs. What he never blamed, what he refused to consider, was the possibility that someone might understand the ship in a way he never could. To him, that bordered on mysticism. And mysticism had no place in military engineering. By the 3rd day of Elias's presence on the carrier, Mendez could no longer remain silent. He confronted General Broussard in a private meeting, arguing that Grant's methods were endangering the integrity of their ongoing procedures. He requested that Elias be removed from technical areas and limited to observational roles only. Broussard listened without reacting, his weathered face giving nothing away. When Mendez finished his appeal, the general asked a single question: "Has your team solved the problem?" The answer, of course, was no. So Elias remained, and that infuriated Mendez even more. Soon, subtle acts of resistance began to appear. Elias would request time alone in key maintenance shafts, only to find, quote, critical testing already scheduled there. Tools he had placed neatly were rearranged or removed. An assistant who had offered to escort him through the lower deck was suddenly reassigned. The passive-aggressive sabotage wasn't overt, but it was enough to slow Elias down. He didn't complain. He expected resistance. This wasn't the first time men like Mendez had underestimated the value of lived experience, and it wouldn't be the last. But what Mendez didn't realize was that every obstacle only deepened Elias's resolve. He understood the true antagonist wasn't a person. It was pride. Not the kind that wore medals, but the kind that refused to admit when knowledge met its limit. Mendez had built a system so advanced it had blinded itself. He had forgotten that technology, for all its power, still served humans. And ships, no matter how sophisticated, were still built with human hands. They still carried human echoes in their steel bones. The real conflict was not just between Elias and Mendez. It was between two ways of seeing the world. One believed that the universe could be conquered through code. The other believed that mastery came from listening, from failing, from returning again and again to the same challenge until it revealed itself. And in the belly of the Armitage, that conflict was reaching its tipping point. Mendez was preparing for one final system-wide recalibration, a complete override of all previous protocols. He believed this would either solve the issue or confirm a fatal design flaw. Elias, meanwhile, had begun to trace the source of a pattern he had felt pulsing through the ship's spine, like a misplaced heartbeat. The confrontation was inevitable, because one of them would be right, and the other would have to face the truth. By the end of the fourth day, Elias had started to notice the rhythm of the Armitage's dysfunction. Not the ship's machinery itself. He'd already begun sensing the deeper irregularity in its pulse, but the people orbiting it, the rituals they performed like clockwork in their attempts to restore her. The pattern was always the same. The engineering teams would swarm the engine core by 7 a.m., each group assigned to a specific subsystem. A dozen or more monitors would blink to life. Specialists in fiber-linked chairs would align their terminals in a circular formation, each reporting a clean diagnostic every 15 minutes. Then, as if trying to will the machine into obedience through sheer force of repetition, they would activate the propulsion systems under simulated deployment conditions. And without fail, somewhere between minute 30 and 50, the system would seize. Not a dramatic failure. There were no explosions or fire alarms, but a slow, choking withdrawal of energy, like the ship was suffocating on its own complexity. After the failure, the reactions were always the same too. Heads would bow slightly, shoulders would tense, and Mendez would tighten his jaw, eyes darting across error logs, muttering something about packet delays or interference loops. He would then suggest another code revision or instruct the AI protocol team to re-optimize the predictive thresholds for mechanical anomaly detection. There was no shortage of ideas, no shortage of data, yet each attempt to tame the ship through numbers ended the same way: silence and disbelief. Elias watched all of it. Not just the machines, but the people. He saw how the technicians avoided eye contact with him, how even the youngest interns had absorbed the skepticism passed down from Mendez's leadership. They didn't hate Elias, not really, but they had been trained to trust code over instinct. A man like Elias didn't fit in their schema. And yet, there he was, every morning before dawn, walking the carrier's decks with his notebook in hand, and no digital readouts to assist him. He would run his fingers over junction points. He would pause beneath low-hanging vents and listen to how the air moved through the ducts. He marked places on the floor with chalk. He sketched the distribution of footfall vibrations with a level of detail that none of the AI simulations had even attempted. It became routine. While Mendez ran his digital rituals, Elias performed analog ones. While the experts huddled around glowing screens, Elias crouched beside forgotten access hatches, feeling for irregularities that weren't captured by software. He noticed subtle patterns in the way certain bulkheads vibrated when the ship powered up. He mapped the propagation of those vibrations and found, to his quiet satisfaction, that they all converged toward a single intersection deep beneath the central propulsion alignment rails, a convergence point no one had thought to examine. It wasn't on any of the updated blueprints, but Elias had lived through the build of carriers like the Armitage. He knew what corners were cut. He knew where original junctions had been buried under the weight of retrofits. Still, each time he requested access to the older layers of the ship's structural archives, his permissions were delayed. And each time he attempted to discuss his theories with Mendez's team, he was met with polite condescension. One engineer even laughed outright when Elias suggested that microharmonic interference between the original thermal dampeners and the AI's predictive modulation system might be causing a resonance feedback loop, one that wouldn't appear on the monitors until real-world loads were introduced. The idea was dismissed as anecdotal noise. Elias said nothing in return. He just made another note in his book and returned to his walking. One afternoon, he stood beside a maintenance chute as two junior techs exited the lower engine tunnel. They were exhausted, complaining about another round of ghost faults that triggered alarms with no source. Elias asked gently if they had checked the panel near junction 7L, beneath the auxiliary coolant distributor. They shook their heads. One muttered that the area had been sealed off after the last refit. It wasn't relevant anymore. Elias just nodded, not pressing them further. But later that evening, when most of the ship had gone quiet and the engineers were off duty, Elias found an older copy of the ship's structural integrity scans. It was just as he'd thought. If that junction had warped even slightly, it could explain the ship's strange behavior. It wasn't broken, it was confused. The ship was trying to follow two sets of orders, one from the new AI integration and one from its older core memory, stored in the metal itself through years of conditioning. The harmonics conflicted in those buried spaces, and like a heartbeat fighting two rhythms, the system shut itself down before things got worse. Still, Elias knew he needed more than theory. He needed proof. But getting to that old junction would require partial disassembly of the surrounding refit layers. No one would approve that, not without some kind of compelling incident. He would have to wait, watch, map. Meanwhile, the pattern continued. Failure, recalibration, failure again. It was as if the ship was stuck in a loop, and everyone aboard was trapped with it. The only person who seemed to understand that Elias might be onto something was General Brossard. He didn't interfere with the specialists, but he began showing up near the engine deck during Elias's walks. He asked no questions, but occasionally glanced at Elias's notes. He didn't need explanations. He trusted results, and he knew the rhythm was leading to a breaking point. Then came the 20th test cycle. It was supposed to be the final simulation before declaring the vessel officially unfit for deployment. Tensions were high. Mendez had personally reviewed every subroutine. The test began smoothly. But at minute 39, the shutdown came again. Only this time, it triggered a new set of cascading alerts that sent red lights flaring through the bridge. The Armitage began venting power through emergency dampeners. Crew members scrambled. Something had changed. Elias, watching from a catwalk above the main engine core, felt a vibration ripple through the ship that wasn't part of the usual pattern. It was sharper, almost like a plea. He turned to the maintenance hatch labeled for junction 7L, still sealed and ignored. In that moment, he knew the ship had shown its hand. She wasn't just malfunctioning, she was pointing. The pattern was no longer theoretical, it had become physical, and now, finally, someone might have to listen. General Stanton's decision sent a ripple through the entire engineering team. For weeks, they had huddled around blueprints, diagnostic screens, and simulation tools, armed with their PhDs and decades of combined experience. Yet they hadn't cracked the code of the failing propulsion system. When Stanton had informed them that he was bringing in a retired Navy veteran, someone they had never heard of, and who had long been out of active service. Some of them had laughed, others had scoffed, and a few had quietly bristled at the idea. To them this was an admission of defeat, a signal that Stanton had lost confidence in their capabilities. Lieutenant Commander Avery Mahoney, the lead propulsion specialist, had spent the better part of his career climbing the ranks through innovation and discipline, and the idea of being overshadowed by an outsider, much less a retired one, left a bitter taste in his mouth. Meanwhile, across the harbor, Willard Granger stood quietly on the deck of the small military boat that was ferrying him toward the USS Leviathan. The skyline shimmered behind him, but his eyes were focused solely ahead. His face, weathered by decades of ocean sun and salt, betrayed no excitement or anxiety. He carried only a small duffel bag, slung over one shoulder, and a crumpled navy cap he kept turning in his hand. To most onlookers, he could have been mistaken for a fisherman or an old dockworker hitching a ride. But beneath that quiet demeanor was a mind that had mapped every inch of the Leviathan's prototype class during its formative years. Willard had been part of the original design consulting team before his early retirement and had seen the foundational flaws others had overlooked, not because he had fancier degrees or better software, but because he had a gut understanding of how the old systems whispered when something was off. When he boarded the aircraft carrier, there was no welcoming committee, no salutes. Just Stanton, waiting near the hangar deck with a quiet nod. They shook hands, firmly, with mutual understanding, and walked side by side through the sprawling maze of metal corridors. Stanton briefed him as they walked, pointing out the areas of concern, the tests already conducted, and the inconclusive results. Willard listened, occasionally muttering a short question, mostly absorbing. They finally reached the engine room, a cavernous, echoing chamber at the heart of the Leviathan. The moment Willard stepped inside, something changed. The constant hum of machinery, the rhythmic pulse of emergency lighting, the scent of oil and coolant. It was like stepping into a church he hadn't visited in years, but somehow still remembered the pews of. Engineers were gathered in clumps, many with arms folded, some looking up with curious disdain. Mahoney was front and center, arms crossed, eyebrow cocked. Stanton introduced Willard with a short explanation, calling him a, quote, veteran consultant. Mahoney offered a curt nod, but said nothing. Willard didn't bother with pleasantries. He simply stepped forward, scanning the room with deliberate slowness, his gaze not just seeing, but evaluating, interpreting, remembering. He asked for silence, and was met with reluctant compliance. Then, without turning, he asked for a paper notebook and a pencil. One of the junior engineers scrambled to get it. For the next 2 hours, Willard barely spoke. He moved along the panels, tapped on pipes, listened closely to the vibrations of the bulkhead, and even removed his boots to feel the hum through the floor beneath his socks. He scribbled notes as he went, consulting nobody, offering no explanations. At one point, he asked Mahoney if the phase shift compensators had been checked with analog diagnostics instead of digital calibration tools. Mahoney, slightly flustered, responded that digital methods were more precise. Willard nodded and said nothing. The silence was unnerving. These were people used to screens, reports, graphs, not silence and intuition. Stanton watched it all unfold from the sidelines, arms folded, face unreadable. But inside he felt something shifting. It was as if the Leviathan itself, this wounded beast of a ship, had recognized one of its own, and was beginning to whisper its secrets once more. Hours passed. Willard finally stood in the center of the room, notebook full of tiny, crowded handwriting, and turned to the team. His voice, when it came, was calm and gravelly. He began to explain, not with superiority, but with clarity, how the issue wasn't in the propulsion software or the fuel injectors, as many had suspected. It was in a micro-hairline fault inside the fourth-phase conversion manifold, which had been masked by automated diagnostics. The ship's internal systems were too modern, too reliant on logic trees that filtered out inconsistencies as statistical anomalies. But to someone who knew the feel of a humming floor panel, the tone of a misaligned turbine, and the drag of energy transfer loss across outdated cabling, it was obvious. He described how the original design had included a redundant bypass, something scrapped later for cost efficiency, that would have flagged this sooner. Silence followed his explanation. Mahoney stared, speechless. Some of the younger engineers looked between each other, eyes wide. Stanton finally spoke and instructed them to follow Willard's diagnosis and implement the inspection. Over the next 2 days, Willard worked side by side with the crew, not as a boss, but as a guide. He showed them how to strip back the modern complexity to understand the bones of the machine. And just as he predicted, the fault was found exactly where he said it would be. Repairs were made, systems recalibrated. On the 3rd day, the Leviathan's engine roared back to life. Not a flicker or sputter, but a full, glorious hum of power. The control panels lit up, stable, balanced, clean. For the first time in weeks, the ship's core systems were in full operational status. There were no cheers, no dramatic fanfare. Just stunned silence, followed by the slow return of motion across the engineering bay. Engineers stepped back from their consoles. Some whispered to each other. Mahoney approached Willard and extended a hand. Willard shook it without a word. Then he turned back toward his notes and made a few final entries. Stanton, watching from the catwalk, allowed himself the smallest smile. The Leviathan had her heartbeat again. The arrival of Silas Briggs on the Eisenhower-class aircraft carrier was marked not by ceremony or fanfare, but by the quiet gravity that accompanied a man who'd seen and done far more than most around him could guess. There was no mistaking that he was not part of the usual military current that swept through the vessel's decks. His presence disrupted the flow in a subtle, almost unspoken way, like a deep current moving beneath a calm sea. While the crew and engineers still labored with their tools, diagrams, diagnostics, and increasingly grim expressions, Silas stepped into the fray with nothing more than a notepad, a pencil behind one ear, and a battered canvas bag that clinked faintly with old tools and oil-stained papers. No one quite knew what to make of him. Some of the younger crew members had been whispering that he was some kind of ghost story, an old sea wolf pulled from retirement as a last-ditch effort. Others were skeptical, wondering if the general had finally lost his patience and brought in a relic to distract from the growing embarrassment. Yet all of them watched, even if they pretended not to, as Silas took his first slow walk across the engine bay. The smell of lubricant, burnt metal, and the soft hiss of coolant systems under pressure surrounded him. He didn't speak, he didn't ask questions. Instead, he listened to the subtle hum of systems trying to compensate, to the faint whine of misaligned gears, to the way the vibrations carried up through the soles of his boots. The engineers had run every simulation they could think of. Diagnostics had been pulled apart and reassembled. Even an AI predictive maintenance system had been deployed in desperation, but it hadn't flagged anything the engineers hadn't already tried. Silas didn't plug into any of it. He didn't so much as glance at a screen. He stood still for long stretches, one hand resting lightly against a bulkhead, eyes closed, his breath slow and deliberate. It was maddening for some, fascinating for others. The general had remained in the shadows since Silas's arrival, giving him full autonomy, resisting the urge to hover or intervene. There was a kind of reverence in that distance, a recognition that whatever Silas was about to attempt needed space, needed silence, and above all, needed faith. On the 2nd day, Silas made his first request. It wasn't for new parts or advanced tech. He asked for the original blueprints, the ones drawn up long before any digital overlays or system patches. They were buried deep in an archive and took hours to retrieve, but once laid out on a folding table in the engine bay, he studied them like a map, back to something long forgotten. His fingers traced each line, each annotation, pausing now and then, as if reliving the choices made by the designers, many of whom were likely long gone. And then he did something that startled everyone. He pulled out a piece of tracing paper and began making his own modifications. They weren't sweeping or dramatic. They were subtle, elegant, almost poetic adjustments to fluid dynamics paths, stress dispersion routes, and torque response zones. He didn't call for assistance. He simply worked, humming lowly under his breath. By the third day, whispers had spread beyond the engine bay. Officers were hearing rumors that the old man was rewriting the way the ship breathed. One technician swore he saw Silas tapping a pipe gently with a wrench, and then muttering, "Too tight here, too tense, needs to exhale more." Some dismissed it as the ramblings of age, but others were beginning to feel something shift, not in the mechanics, but in the mood. Tension was still high, but there was now a pulse of curiosity, a flicker of hope, that maybe, just maybe, this man was more than a desperate last attempt. Then, late on the fourth night, something extraordinary happened. Silas asked for a 5-minute solo test run, just him, in the engine bay. The team hesitated. Regulations demanded multiple supervisors and layered monitoring, but the general overrode them with a simple nod. They granted the request. Silas made 3 adjustments, each involving manual tweaks to key pressure valves that hadn't been touched in weeks for fear of triggering further failure. He adjusted the alignment of a long-forgotten balancing rod with nothing more than a shim and a feeler gauge, then stepped back. The chief engineer, who had been reluctantly observing from the catwalk above, leaned in as the turbines began to spin up. There was a shudder, then a groan, and then silence. Not the kind that meant the system had failed again. This was different. It was the silence of perfect alignment, the absence of the grinding, the whirring, the struggle. For the first time in over a month, the ship's heart was beating in rhythm again. When the system fully powered up, running hotter and cleaner than it had in weeks, the technicians began flooding in, unable to believe what they were seeing. Vibration sensors returned to baseline. Thermal readings dropped into green zones. The harmonic balance that had eluded their algorithms was now stable. Silas didn't smile. He simply took off his gloves, folded his tracing paper, and began packing his tools. The room was still for a long moment, and then a slow wave of applause broke out. Not raucous or performative, but grateful, reverent, the kind of applause reserved for moments of shared awe. The general stepped into the room, arms folded, eyes narrowed in something between pride and vindication. Silas, brushing a thin layer of dust from his sleeve, looked up and gave the faintest nod. The battle wasn't over, but a turning point had been reached, and everyone present knew they had just witnessed something far greater than a fix. They had witnessed the return of wisdom in an age of automation, the proof that sometimes, to move forward, you had to bring back the hands that had once built the path. The ship breathed easier that night, and so did its crew. The room fell silent for a moment as everyone turned to look at the old man standing by the threshold. Commander Nathaniel Briggs walked in with the quiet confidence of a man who had seen more battles, solved more impossible problems, and outlived more mechanical systems than anyone present could imagine. His uniform was gone, replaced by a weathered denim jacket over a faded gray t-shirt, and his gait, though slightly stiff from age, still had the bearing of authority. He looked around the briefing room of the aircraft carrier, scanning the faces of the younger engineers and officers before resting his eyes on General Halverson. The general offered a simple nod, and Briggs returned it before stepping forward. There was a mix of curiosity and skepticism in the room. A few of the younger specialists exchanged quiet glances, clearly unsure what this man could offer that their teams hadn't already attempted. To them, he was just another retired veteran being brought in on a whim, a symbolic gesture from an aging general grasping at straws. But for Halverson, and a select few senior officers who had read the reports of Briggs' previous deployments, this man represented something rare, lived experience under extreme pressure, and an intuitive understanding of these ships that couldn't be taught in a classroom or simulated in a lab. Briggs said nothing for a moment. He simply approached the central table where the schematics were spread out, picked up a marker, and began circling areas on the blueprint of the carrier's propulsion system. He made no grand statements, no introductions, just a quiet, focused review of the engine room diagrams as if he were reacquainting himself with an old friend. The others watched as he moved with a kind of meditative rhythm, pausing only occasionally to scribble notes or mutter under his breath. Finally, he straightened up and asked to be taken to the engine room. No one questioned it. There was something in his calm assertiveness that cut through the usual hierarchy. The general gave a brief order, and an escort was assigned. On the way down, Briggs asked for the maintenance logs, handwritten if available, not just the digital records. He wanted to see the notes left by the engine techs, the small annotations that never made it into the official reports. He explained that machines like these often spoke through subtle signs, heat patterns, vibration rhythms, even the smell of the air in the engine chamber. And those signs were often lost in translation through digital data. When they finally reached the engine room, Briggs stood at the entrance for several seconds, taking in the scene. The towering turbines, the intricate piping, the layers of protective shielding, and the forest of gauges all pulsed in quiet tension, as if waiting for someone who knew how to truly listen. The scent of grease and ozone filled the air, and somewhere in the background, the faint hum of auxiliary systems throbbed like a distant heartbeat. Briggs moved slowly, not from age, but from deliberate intention. He ran his fingers along the edges of the turbine housing, knocked gently on a few sections of pipe with the back of his knuckle, then crouched beside one of the main drives. The team that had been working down here for weeks watched from a distance, unsure whether to intervene or observe. Some whispered among themselves, trying to guess what he was doing, but Briggs ignored them entirely. After nearly an hour of silent observation, subtle listening, and moving from one subsystem to the next, he finally asked for the power to be cut to a specific series of cooling ducts. He pointed to one section of the machinery and said he wanted to open it up. The request was met with resistance from one of the junior engineers, who warned that tampering with that section could destabilize the balance in the temporary power loop. Briggs looked at him, nodded slowly, and calmly stated that it was precisely that imbalance that was contributing to the shutdown spiral they kept encountering. It wasn't a full mechanical failure, he explained. It was a systemic reaction to a localized disruption in a heat venting protocol that had been modified sometime in the last 5 years. Something about the update to the auto-cooling redundancy layer didn't match the original configuration the ship had been built with. He asked to see any records of retrofitted cooling units. After some digging through maintenance records, they discovered that, indeed, one of the subcontractors had installed an alternative component in that specific cooling node, approved by the manufacturer but never fully tested on this class of carrier. It wasn't a bad component, per se, but it created a cascading issue when paired with the ship's older analog override systems. Briggs took a deep breath and requested a short window, just 30 minutes, to attempt a manual reset of the component's thermal failsafe and reroute its output through a legacy bypass loop that hadn't been used in over a decade. He assured them no harm would come to the system if they followed his instructions precisely. After a tense consultation with Halvorsen, clearance was granted. The room buzzed with quiet anticipation as Briggs, assisted by a reluctant but respectful group of engineers, began the process. Every movement he made was calculated and efficient. No wasted actions, no hesitation. He wasn't just repairing a machine. He was communing with it, interpreting its language through decades of muscle memory and intuition. As the final adjustment was made, Briggs gave a simple nod. "Now bring it online," he said. The lead systems engineer activated the primary sequence. For a moment, nothing happened. Then the whirring began, slow at first, like a groggy giant waking from slumber. Then the turbines began to spin with a steady rhythm. The hum deepened into a confident roar. Gauges spiked into the green. Pressure systems stabilized. And most importantly, no emergency shutdowns. No fault loops. The carrier's heart was beating again. A stunned silence overtook the control deck before it erupted into applause and disbelief. One of the young technicians ran to check the real-time metrics, and sure enough, everything held steady. Systems that had failed repeatedly for weeks were now running with precision. Commander Briggs didn't gloat, he didn't smile. He simply took a step back and exhaled, as if closing a chapter of an old, unfinished book. For the first time in a long while, the USS Wallace was alive again. And it was thanks to a man no longer on active duty, whose experience and quiet mastery had succeeded where every protocol and expert had failed. But the story wasn't finished. What came next would surprise even the general. Under the low-humming lights of the maintenance deck, tension had tightened into every corner of the USS Freedom's engine control room. Despite the team's best efforts, despite the piles of diagnostics and flowcharts, the twin-reactor propulsion system remained unresponsive. Every tool had been used, every line of code reviewed, every subsystem torn down and rebuilt, and still, the massive ship was a dead weight, floating listlessly in the Pacific. Admiral Warren's voice echoed in Ensign Torres's mind as she anxiously reviewed the last set of logs again. "We don't need another theory, we need that engine back online. Or every drill, every deployment, every strategic advantage we've built for 5 years will be moot." The phrase carried more than pressure. It carried the weight of potential international embarrassment. The Freedom was more than a symbol of American naval dominance. It was a signal to the world that they still commanded the seas. And it sat immobile, silent and stubborn, as if mocking every degree and title of the men and women who had worked on it so far. Meanwhile, in a modest guest quarters at the far end of the ship, retired Chief Engineer Silas Grant stood at the narrow window, staring at the water beyond with a distant, unreadable expression. He hadn't said much during the brief orientation. No demands, no ego, just an old man in a faded Navy-issue jacket, moving with a limp in his left leg that he hadn't bothered to explain. General Halvorsen had insisted on bringing him in, a personal decision that raised more than a few eyebrows among the chain of command. What could an old, out-of-practice mechanic offer that a multi-million-dollar team of MIT-trained experts couldn't? But the general, who had served beside Grant in the first Gulf deployment, didn't waver. And now here Grant was, alone, sipping black coffee from a mug labeled "Property of Deck 4", which someone had handed him on his way in. When Ensign Torres entered the room to deliver the latest status update, she found Grant sketching something on the back of a printed circuit diagram using nothing but a blunt pencil and decades of intuition. She paused, uncertain whether to interrupt, but he glanced up before she could speak. She expected a question, maybe something technical, but instead, he just asked if she'd ever felt like she was standing in the wrong century. Before she could answer, he chuckled softly and said, "Engines speak the same language, no matter what decade they're born in. You just have to shut up and listen long enough to hear them." Then he handed her the sketch. It wasn't a technical schematic exactly, more of a conceptual map showing the propulsion system's energy flow through the ship in a manner that felt intuitive rather than scientific. She couldn't make complete sense of it, but something about the layout made her hesitate. It wasn't like anything the team had presented. It was simpler, but also more human, as if the ship were a living organism instead of a pile of metal and logic. Within the hour, Grant was escorted to the main engineering bay, flanked by 2 skeptical officers who treated him less like a savior and more like a liability. But when he stepped onto the graded floor and looked around, something changed. His eyes narrowed with focus, his steps became more deliberate, and without asking for permission, he began touching things. Panels, piping, exhaust ports, as if greeting old friends. He ran his fingers along the surface of a fuel injector, knocked twice on a coolant line, and then squinted toward the primary control unit like a man reading an old novel he'd memorized years ago. The officers exchanged glances, but didn't stop him. Instead, they followed him as he made his way to the auxiliary access panel beneath the main deck. He requested that the magnetic locks be disengaged and that he be given a length of insulated copper wire. No one understood why, but General Halvorsen gave the nod. Then, like a conductor preparing an orchestra, Grant took a slow breath and opened the panel. The space was cramped and dark, but he seemed to know exactly what he was reaching for. A minute passed, then 5, then 15. Silence swallowed the room, and then he spoke. Just one sentence. "There's a pressure inversion loop in the bleed line. It's backfeeding into the thermal regulator. That's why your diagnostics don't see it." The chief propulsion officer frowned. "That's impossible. We'd have seen the pressure drop." But Grant simply pointed. "You measured output. I'm talking about reverse resonance. It's there, bypassing your sensors, caused by a magnetic feedback trace from the backup converter coil you installed during dry dock. You all assumed it was irrelevant." Silence. Then a rush of motion. Teams scrambled to verify, and within half an hour, his words were confirmed, down to the decimal. Not only had Grant identified a problem no one else had found, he'd done it without needing to run a single test. It was the kind of moment that shifted the atmosphere in the room. The skeptical looks became wide eyes. The clipped tones softened into respectful silence. And when Grant calmly stepped back from the open panel and wiped his hands on his jacket, the youngest technician on the floor whispered, "How the hell did he even see that?" But Grant wasn't looking for validation. He merely nodded, looked up at the massive overhead pipes, and said, "Now we purge the loop, recalibrate the regulator, and give her room to breathe. She'll wake up on her own after that." They followed his instructions, exactly as given. No edits, no debates, just execution. And slowly, as systems reactivated and readings normalized, a low hum returned to the ship's engines. For the first time in weeks, the USS Freedom showed signs of life. It wasn't a full ignition yet, but it was the first real heartbeat in a long, paralyzing silence. The morning sun bore down hard on the steel deck of the vessel as Grant crossed back over the gangway, returning to the aircraft carrier after having spent another long night inside the base's off-site engineering hangar. He looked exhausted, but more resolute than ever. He had spent hours reviewing engine layouts, recalibrating models, and double-checking his assumptions against the original specifications. The man's brain had become a living schematic, each gear and bolt etched into memory. But what he brought back with him today was more than theory. It was intuition, the kind born of blood and oil, of long nights at sea, of machines whispering their secrets to the one man who truly listened. Colonel Maddox met him at the entrance to the lower deck, expression unreadable, flanked by 2 engineers with clipboards. Word had already spread that Grant had a plan, one that defied all modern diagnostic paths. Maddox gave a terse nod and motioned for the group to follow. They descended together into the heart of the ship where the engines sat in silence, not broken exactly, but listless, powerful beasts without breath. Grant moved through the chamber slowly, reverently, like a man reuniting with an old friend whose silence had grown too long. He walked past every engineer, past the computer panels, ignoring all the blinking lights and data streams. He stopped in front of the turbine coupling, the massive joint that connected multiple shafts across the propulsion line, and ran his gloved hand along the edge of a barely perceptible weld seam. That's when he asked for everyone to clear the floor except 2 machinists and an apprentice welder. Maddox bristled, but nodded. Slowly the engineers and officers backed off, one by one, retreating into the glass control room above. From there, they could still observe, and they did so with skepticism and arms crossed tightly across chests. The moment they were alone, Grant pointed to the seam and asked the welder to bring in a thermal lance cutter and a cold spray unit. It was clear he wasn't going to rely on fancy 3D modeling or predictive software. He was listening to the ship, its creaks, its groans, the subtle tremors of deferred maintenance and mechanical fatigue. With surgical precision, the cutter sliced into the seam, releasing a puff of gas that carried the unmistakable stench of aged turbine oil and scorched insulation. Grant leaned in and squinted. A hairline fracture. Not on the surface, but on a subsurface insert welded decades ago and long forgotten in digital schematics. A small misalignment of materials had caused a micro-friction point, imperceptible at low speeds but disastrous at scale. This flaw, though invisible to sensors, created minute vibrational inconsistencies that confused the onboard diagnostic AI. In short, the engine was not malfunctioning. It was miscommunicating with itself. Grant called for a borescope and slid the cable into the narrowest access pipe. The screen above flickered to life, revealing corrosion patterns and a pair of misaligned rotary fins. They weren't broken. They had simply been mounted with a tolerance too tight for postmodern operational ranges. It was an old-school assembly problem, something no algorithm could flag, but any naval veteran from the Cold War era would recognize. When Maddox returned to the floor, Grant handed him a clipboard with a list: 10 parts to be machined by hand, 3 components to be reset with older calibration tools, and a 4th that needed to be completely rebuilt according to its 1981 blueprints. Maddox looked over the list, eyebrows raised, but he didn't argue. He authorized the work without calling for further approval. For the next 48 hours, the ship's engine room transformed. The noise of machinery returned, not the panicked whir of failing systems, but the purposeful grind of restoration. Grant oversaw each measurement, guiding the younger machinists with an unshakable calm. He didn't bark orders. He offered stories of how ships used to breathe, how engines used to sing when aligned just right. Engineers once too proud to ask questions now huddled around him, notebooks open, minds racing to catch up. And somewhere in the middle of the chaos, something shifted. Respect grew, not out of rank or credentials, but out of the quiet clarity with which Grant diagnosed a failure that no one else even knew existed. By the third night, the final component had been fitted, sealed and pressure tested. Grant stepped back and folded his arms. For the first time in weeks, he allowed himself a small breath of relief. The reassembly was complete. Maddox stood by, silent. The moment had come. One by one, systems powered up. Red turned to green across every board. The sound of turbines spinning in unison echoed through the steel halls, building into a rhythmic harmony that vibrated through the bulkheads like a living heartbeat. For a moment, the control room stood still, as if in awe of what had just occurred. Then, a soft cheer erupted, subtle but genuine. Grant didn't cheer. He simply closed his eyes and placed a hand on the wall, feeling the pulse of the ship once more. It was back. Alive. Functional. Ready. But as he stood there, letting the moment settle in, he knew this wasn't the end of the journey. This engine's silence had only been a symptom. There were deeper forces at play, decisions made far from the decks and chambers, choices that overlooked wisdom in favor of shiny credentials. And now, with the ship functional again, the spotlight would return. Political eyes, media interest, questions about why one old man had succeeded where teams of certified experts had failed. Grant knew all of that was coming. But in this moment, none of it mattered. The ship was breathing again, and the sea, in all her silence, was listening. The day the USS Freedom's engine room hummed back to life marked more than just a mechanical victory. It was the unveiling of a hidden legacy that had quietly endured beneath layers of modern bureaucracy and over-reliance on technology. His news traveled quickly through the ranks, and soon the entire carrier's crew knew the name Silas Grant, the retired chief engineer whose steady hands and deep knowledge had unraveled the mystery that had confounded an elite team of specialists. His story, once confined to hushed whispers and skeptical glances, now carried the weight of undeniable truth and respect. It began with the discovery that the ship's propulsion system, a marvel of contemporary engineering, harbored an overlooked flaw, one born not from design failure, but from decisions made long after its launch to retrofit and modernize components without fully appreciating their intricate interplay. The piece of the puzzle no one else had seen was buried deep in the analog systems and physical alignments that digital diagnostics routinely ignored. As the Freedom's engine roared with renewed vigor, the ship itself seemed to reclaim a part of its identity, a spirit embodied in the steady, methodical work of Grant and those who had finally listened. The Navy leadership quickly recognized the broader implications. A public briefing was arranged in the ship's hangar bay, attended by senior officers, engineers, and key members of the media. Standing at the podium, General Halvorsen spoke of the triumph not just as a technical success, but as a testament to experience, humility, and the value of looking beyond the latest technology for wisdom that sometimes comes from the past. He praised Grant's contributions, highlighting how one man's lifetime of hands-on expertise bridged the gap between the digital age and the practical realities of naval engineering. Cameras flashed as Grant stepped forward, stoic but resolute. He spoke modestly, crediting the team and emphasizing that the ship had spoken to him, reminding everyone that the vessel was not merely a collection of parts, but a living system that required respect and understanding. His remarks resonated deeply, inspiring not just those in uniform but the public watching through news broadcasts. The narrative shifted from one of failure to one of resilience and intergenerational collaboration. Yet not everyone was pleased. Some within the defense industry and contracting circles bristled at the implication that newer, more expensive systems had been outperformed by old-school know-how. Quiet conversations behind closed doors questioned how a retired engineer could bypass layers of sophisticated technology and bureaucratic oversight. But the Navy stood firm. The Freedom's revitalization was a message. Progress must be balanced with wisdom, and respect for legacy systems cannot be abandoned in pursuit of novelty. Internally, the ripple effects were profound. Grant's success sparked a renewed interest in mentorship programs, pairing seasoned veterans with younger engineers to share knowledge that no manual or simulation could capture. Workshops were organized, focusing on the physical feel of ships, the subtle cues that signal impending failure long before alarms sound. This cultural shift breathed new life into the Navy's engineering core, blending cutting-edge innovation with practical experience in a way that promised greater reliability for future missions. For the crew of the Freedom, daily life began to change too. Confidence surged as systems stabilized and the looming threat of extended downtime faded. The ship's operations gradually ramped up, training exercises resumed, and morale climbed steadily. Crew members, who had endured weeks of uncertainty, now found inspiration in Grant's story, the reminder that every individual, no matter their rank or current role, could be a catalyst for change. Beyond the ship, Grant's legacy spread through conferences and naval symposiums where he was invited to speak. His message was consistent: listen deeply to your machines and your people, respect history, and never underestimate the power of hands-on experience. His presence challenged assumptions, bridged generational divides, and redefined how success was measured in high-stakes environments. The antagonist in this case was not a person but a systemic arrogance, a blind faith in technology that overshadowed the nuanced realities of the physical world. Grant's vindication served as a corrective force, a reminder that true mastery blends the new with the old, that progress without humility can be dangerous. And so, the public vindication was not just about a single man or a single ship. It was about restoring balance in an era racing toward automation and digital supremacy. Justice, in this context, meant honoring the quiet heroes, whose wisdom often goes unseen and unappreciated. As the Freedom prepared for its next deployment, the ship itself seemed to carry the legacy forward, a symbol of resilience, adaptation, and the timeless value of human insight. In a world of flashing screens and rapid change, the aftermath of Silas Grant's intervention rippled through every layer of the USS Freedom's operations and beyond. What began as a mechanical fix evolved into a profound shift in relationships, attitudes, and priorities aboard the vessel and within the broader naval community. The crew, once weighed down by frustration and uncertainty, found themselves buoyed by a renewed sense of purpose. The invisible tension that had filled the air like static was replaced by a collective exhale. Officers and engineers who had once questioned the wisdom of bringing a retired veteran back into the fold now approached Grant with respect, seeking guidance and acknowledging the depth of his expertise. This change wasn't merely professional. it was deeply personal. Many younger crew members, particularly those early in their naval careers, saw in Grant a mentor and living example of perseverance and humility. He wasn't just a problem solver. He was a teacher who conveyed lessons, not through lectures but through lived experience and quiet presence. Training sessions shifted to include hands-on workshops, where veterans shared the feel of engines and systems in a way no textbook could capture. Meanwhile, the Navy's leadership, invigorated by the success, began implementing structural changes. Task forces were created to assess how to better integrate retired experts into active projects, recognizing that institutional knowledge was a resource too valuable to be left on the sidelines. The Department of Defense issued memos encouraging collaboration across generations, balancing cutting-edge technology with time-tested practices. Publicly, Grant's story became a beacon of resilience and practical wisdom, widely covered in military publications and popular media alike. The narrative of an old chief engineer solving a crisis that modern technology couldn't had a universal appeal that transcended the confines of naval circles. It inspired discussions about the value of experience in an age dominated by rapid technological change and automated systems. This cultural shift also exposed some uncomfortable truths. Internal reviews revealed that budget constraints and overconfidence in new systems had led to shortcuts in retrofitting the Freedom's propulsion components, contributing to the failures. These findings prompted a re-evaluation of maintenance protocols and supplier oversight. While no direct blame was placed on any individual, the organization acknowledged that progress should never outpace prudence. The ripple extended even to the engineers who had initially doubted Grant's approach. Their attitudes evolved from skepticism to appreciation. They embraced a more holistic view of systems engineering, one that combined data analysis with hands-on intuition. Some even pursued additional training in legacy systems, eager to bridge gaps that had previously gone unnoticed. Relationships between departments improved as collaboration became more fluid and less siloed. General Halverson, recognizing the importance of these shifts, pushed for annual workshops on naval engineering history, inviting veterans to share stories and technical insights. These sessions became popular not just for their educational value, but for the morale boost they provided. On a broader level, the Navy's renewed commitment to honoring experience influenced recruitment and retention policies. Efforts increased to create career pathways that encouraged long-term service and knowledge sharing, combating the rapid turnover that threatened institutional memory. In the day-to-day life aboard the Freedom, the change manifested in practical ways. Maintenance schedules were revised to include checks inspired by Grant's observations. Engineers carried with them a deeper awareness of the ship as a living system rather than just machinery. The esprit de corps was palpable. The crew knew they had overcome a crisis not just through technology, but through human connection and respect. Beyond the Freedom, Grant's legacy sparked conversations across military branches and allied navies. His story was cited as a case study in leadership seminars and engineering conferences worldwide. The integration of veterans into modern technical roles gained momentum, and academic institutions began incorporating practical experience modules into engineering curricula. For Grant himself, the aftermath brought a quiet sense of fulfillment, but also humility. He understood that his work was part of a larger continuum, an ongoing dialogue between past and present, between human hands and digital interfaces. Though his role was no longer that of an active engineer on the front lines, his influence permeated the culture, becoming a standard for how wisdom and innovation could coexist. The antagonist, nameless, systemic complacency, and blind faith in untested technology had been challenged but not defeated. The Navy remained vigilant, aware that such crises could arise again without continued diligence. Yet the lessons learned ensured that when the next challenge came, it would be met with a balanced approach grounded in respect for both history and progress. In the end, the USS Freedom sailed on, not merely as a machine of war, but as a symbol of growth, adaptation, and the power of collaboration. The legacy left in the wake of Grant's intervention was not only a repaired engine, but a repaired mindset, a transformation that embraced complexity without losing sight of humanity. The ship's crew, once fractured by doubt and frustration, now moved forward, united in purpose and pride. And in every hum of the engines, in every creak of the hull, there echoed the quiet wisdom of a man who had listened long enough to hear what the machine was really trying to say. The transformation that began with the revival of the USS Freedom's engines extended far beyond the metallic walls of the ship and into the very fabric of naval tradition and culture. Silas Grant's success in diagnosing and repairing a fault that had eluded a fleet of modern specialists became a powerful symbol of how timeless wisdom and experience could shape the future. His story spread through naval academies, military symposiums, and engineering circles worldwide, inspiring a new generation of officers and technicians to value the deep knowledge of their predecessors alongside emerging technologies. The legacy of that pivotal moment was not just a repaired engine or a restored vessel, but a lasting shift in how the Navy perceived expertise and innovation. It underscored the importance of blending human intuition with the precision of digital tools, reminding all that machines, no matter how advanced, required the guiding hand and attentive mind of those who truly understood their history and spirit. Educational institutions took note, integrating practical, hands-on learning experiences into curricula, inviting retired veterans like Grant to share their stories and skills with young engineers. This intergenerational exchange created a vibrant learning environment where past and present merged, cultivating problem-solving approaches that were both technically rigorous and deeply informed by real-world experience. On the operational front, the Navy implemented new policies aimed at preserving and transferring institutional knowledge. Veteran mentorship programs were expanded, and a renewed emphasis was placed on maintenance practices that honored the physicality of naval engineering rather than relying solely on automated diagnostics. The culture shifted from one that sometimes prioritized speed and cost efficiency to one that embraced thoroughness and reverence for complexity. The broader impact rippled through allied navies as well. Partner forces studied the Freedom's revival as a case study in resilience and adaptability, adopting similar approaches to integrating veteran expertise and balancing technological advancements with legacy system understanding. International naval conferences featured panels dedicated to the lessons learned from the incident, fostering collaboration and mutual respect among allies navigating the challenges of modern maritime defense. For the crew of the Freedom, the change was tangible and deeply felt. Morale soared as they saw their vessel not just as a tool of war, but as a living legacy shaped by generations of hands and minds. Daily operations carried new meaning. Routine maintenance was no longer a chore but a sacred duty to uphold a tradition of excellence and care. The ship sailed with renewed purpose, a testament to the enduring power of wisdom and the human spirit. Silas Grant, though retired from active duty, became a revered figure in naval circles. His humble approach and quiet dedication inspired countless individuals to seek balance between innovation and tradition. He was invited to speak at conferences, mentor young engineers, and consult on projects aimed at bridging the gap between cutting-edge technology and tried-and-true methods. His influence helped shape a future where experience was celebrated as an invaluable asset rather than an outdated relic. In a world increasingly driven by automation and rapid change, Grant's story delivered a timeless message. Progress is most powerful when it honors the past. His legacy encouraged leaders and innovators to cultivate patience, listen deeply, and value the lessons embedded in every rivet and circuit. The aircraft carrier, once crippled by a problem no one else could solve, now stood as a beacon of this philosophy, its engines not just restored but imbued with meaning. The moral of the story was clear. True mastery arises from the harmony of knowledge, respect, and dedication across generations. The call to action resonated beyond the military. In every field, from engineering to leadership, success depends on recognizing the importance of experience, fostering collaboration, and embracing humility. The lasting impact of Silas Grant's work was a reminder that no matter how advanced our tools become, The human element remains the heart of innovation and resilience. The USS Freedom's journey from near failure to triumph illustrated this truth vividly, inspiring others to listen, learn, and lead with wisdom born of both history and hope. Part 13 unfolded as the USS Freedom continued its voyage, no longer just a symbol of military might, but a living testament to resilience and the power of legacy. The ship's renewed vitality stirred pride among its crew, who now carried with them the story of how a retired veteran's wisdom had revived their vessel against all odds. This narrative became a cornerstone of their identity, inspiring every sailor and engineer to see themselves not just as operators, but as guardians of a rich heritage. The daily routines aboard the Freedom transformed subtly, but significantly. Maintenance checks were conducted with an attentive reverence, technicians and officers alike understanding that each bolt and panel held the imprint of decades of service and sacrifice. Young engineers sought out veterans to glean insights that manuals and sensors could not provide, fostering a culture of mentorship and mutual respect. Silas Grant's presence, though no longer physical aboard the ship, permeated the atmosphere like a guiding force. His influence encouraged a mindset that valued patience over haste, observation over assumption, and humility over hubris. This shift was evident in how the crew approached challenges, embracing a balanced perspective that blended cutting-edge technology with time-tested techniques. Outside the ship's decks, the Navy institutionalized these lessons. Training programs were revamped to emphasize hands-on experience alongside digital proficiency. Retired personnel were actively recruited as consultants and mentors, their invaluable knowledge recognized as a strategic asset rather than an outdated relic. Research initiatives began exploring ways to integrate veteran insights into system designs, ensuring future vessels could benefit from this blended wisdom. The impact extended internationally as allied navies took note of the Freedom's transformation. Conferences and joint exercises highlighted the importance of honoring legacy systems and fostering intergenerational knowledge transfer. This global dialogue reinforced the understanding that technology alone was insufficient. Human experience remained the keystone of effective maritime operations. Media coverage portrayed the Freedom not just as a warship, but as a symbol of enduring strength, adaptability, and the unbroken chain of expertise linking past to present. Public interest grew in the personal stories behind the technical triumphs, emphasizing themes of perseverance, collaboration, and respect for tradition. These narratives resonated far beyond naval circles, inspiring broader discussions about the role of experience in an increasingly automated world. Back aboard the Freedom, the crew's morale and cohesion flourished. Shared stories of the crisis and recovery became part of the ship's culture, told during long watches and quiet moments. New recruits heard of Silas Grant's quiet determination and the lessons learned from his work, instilling a sense of pride and responsibility. Officers encouraged open communication and valued input from all ranks, fostering an environment where wisdom was shared freely rather than hoarded. The antagonist force, represented by complacency, over-reliance on untested technology, and disregard for practical knowledge, was effectively countered by this cultural evolution. The ship sailed with a renewed sense of purpose, ready to face future challenges with confidence rooted in a comprehensive understanding of both machine and human. Silas Grant's legacy thus became more than a single act of repair. It was a catalyst for transformation, reshaping attitudes and practices that would safeguard the Freedom's operational readiness for years to come. The broader message inspired leaders across fields, embracing the lessons of the past, valuing diverse perspectives, and maintaining humility in the face of complexity are essential to true progress. As the USS Freedom cut through the waves, propelled by engines restored not only mechanically but spiritually, it embodied a narrative of resilience and collaboration. It stood as a beacon for all who believed that innovation thrives best when grounded in respect for history and human insight. This story, born from a retired veteran's unwavering dedication, was now etched into the very fabric of the ship and its crew, a lasting reminder that sometimes the greatest solutions come not from the newest technology, but from the patient, experienced hands willing to listen and lead. The USS Freedom had long been a symbol of strength and technological prowess, but the crisis it faced and the solution it found in Silas Grant became a defining chapter in its storied history. As word of the veteran's remarkable achievements spread throughout naval circles and beyond, the story evolved from a mere technical fix into a powerful narrative about the enduring value of experience and the courage to trust in it. This chapter began to inspire a broader cultural shift, not only within the Navy, but across industries where reliance on automation and technology sometimes eclipsed the wisdom of seasoned practitioners. On board the Freedom, the aftershocks of change manifested in numerous ways. The officers, once skeptical, now embraced a leadership style that welcomed input from all levels, recognizing that innovation thrived best in collaborative environments. Engineering teams found renewed motivation, driven by the knowledge that their work was part of a living tradition that valued patience, precision, and a deep understanding of systems as more than just data points. Mentorship became more than a buzzword. It was a daily practice. Experienced sailors and retired veterans regularly held workshops and informal sessions, where stories, techniques, and lessons were exchanged. These gatherings helped bridge generational divides, fostering mutual respect and enhancing operational readiness. Technology, while still central, was now complemented by this human dimension, creating a synergy that promised greater resilience and adaptability. The Navy institutionalized these lessons. Training curricula were updated to include modules on the history and evolution of naval engineering, ensuring that new recruits developed an appreciation for the systems they would operate. Programs to reintegrate retired personnel as advisors gained traction, providing invaluable perspectives that bridged past and present. Investment in practical, hands-on training increased, balancing the rapid advances in simulation and automation with tactile learning. Internationally, the Freedom's experience became a case study in balancing modernization with heritage. Allied navies adopted similar approaches, recognizing that technology alone could not replace the insights gained from years of service and experience. Conferences highlighted the importance of veteran involvement in training and system design, and collaborative efforts were launched to preserve institutional knowledge in an era of fast-paced change. The public, too, responded to this narrative with enthusiasm. Media outlets featured in-depth stories about the crisis and resolution, humanizing the technical challenges and emphasizing the themes of perseverance, humility, and the power of listening. The tale of Silas Grant's quiet expertise and the ship's revival resonated widely, sparking conversations about the role of experience in leadership and innovation across sectors. For the crew of the Freedom, this legacy infused daily life with meaning. They sailed not just as operators of advanced machinery, but as custodians of a tradition that honored the past while embracing the future. This mindset fostered a culture of respect, collaboration, and continuous learning, where every member felt empowered to contribute their unique perspective. Challenges were approached with a balance of confidence and caution, informed by both data and the collective wisdom of the crew. The antagonist that had once manifested as systemic complacency and over-reliance on technology was now countered by an evolving culture that valued depth over speed, understanding over assumption. The Freedom's engines hummed with renewed vigor, propelled by more than just fuel and mechanics. They were driven by a renewed commitment to excellence, resilience, and the enduring value of human insight. Silas Grant's story, once a singular event, became a catalyst for ongoing transformation, reminding all who served that true progress is measured not only by technological advancement, but by the ability to learn from the past and adapt with humility and respect. The aircraft carrier, cutting through the vast ocean, stood as a beacon of this philosophy, a living testament to the power of experience and collaboration in a rapidly changing world. Its journey illuminated a universal truth, that the greatest strength lies in the harmony between innovation and tradition, between the latest tools and the timeless wisdom of those who came before. As the sun set over the horizon, casting golden light across the Freedom's decks, the ship and its crew carried forward a legacy of resilience and hope, an inspiration to all who believe in the enduring power of knowledge, dedication, and the human spirit. The story of the USS Freedom's revival, sparked by Silas Grant's return and expertise, left an indelible mark far beyond the steel confines of the ship itself. It became a living legend, a tale of quiet heroism and the profound impact one individual's dedication can have on an entire institution. As the carrier sailed the open seas once more, its engines resonating with a newfound vigor, the legacy of that pivotal moment continued to inspire a lasting transformation across the Navy and beyond. Grant's story embodied a broader message about the importance of humility, perseverance, and respect for experience in a rapidly evolving world. It reminded leaders and innovators in every field that progress is not solely measured by the latest technology or data, but by the wisdom to know when to trust human insight, especially that born of hard-earned lessons and years of service. The ripple effects extended into leadership philosophies, training programs, and operational strategies. The Navy embraced a culture that honored the past while confidently stepping into the future, recognizing that true innovation requires a balance between cutting-edge tools and the seasoned judgment of those who understand the nuances behind the machines. Mentorship became institutionalized, creating bridges between generations and fostering environments where knowledge flows freely. This fusion of old and new not only enhanced technical capabilities, but also strengthened morale, resilience, and cohesion. The USS Freedom itself became a symbol, not just of naval power, but of the enduring spirit that drives human progress. Its story was shared in classrooms, boardrooms, and conferences worldwide, inspiring individuals to listen more closely, to value diverse perspectives, and to approach challenges with patience and respect. Silas Grant, once a retired engineer brought back for one last mission, became an icon of the quiet strength that lies in experience and dedication. His legacy encouraged others to embrace lifelong learning, to mentor generously, and to remember that every system, no matter how complex, ultimately depends on the people who build, maintain, and care for it. In an era dominated by rapid technological change, this message resonated deeply, offering a roadmap for sustainable success rooted in collaboration and humility. The antagonist in the story, the complacency born from over-reliance on untested systems and the dismissal of seasoned wisdom, had been confronted and transformed. The crisis on the Freedom served as a cautionary tale, urging vigilance and balance in the pursuit of progress. The ship's revival was more than a technical achievement. It was a testament to the power of listening, learning, and honoring the lessons etched in both metal and memory. As the Freedom continued its journey across the vast oceans, it carried with it the collective hope of a future where innovation and tradition coexist in harmony. Its engines, once silent, now sang a song of resilience and renewal, a reminder that sometimes the greatest breakthroughs come not from new inventions, but from the steady, patient hands willing to listen and act. This story, woven into the fabric of naval history, stands as an enduring inspiration to all who seek to lead with wisdom, to innovate with respect, and to build a legacy that will outlast the fleeting moments of triumph. The USS Freedom's journey, marked by struggle and redemption, exemplifies how true greatness arises when experience and progress unite, lighting the way for generations to come. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.